Very good morning. Salam Sejahtera, and very happy to see some of the familiar names here, and welcome back again. For these regular sessions, we're going to have in July, and hopefully that will resume sometime in September again. As we mentioned in email, and you've seen on Facebook and some social media, we are not going to have these regular sessions like that, 45 minutes free every time. But for the recent MCO, we hope that we will try to contribute to the community so that people will take the chance to learn from home with the latest technology. Hopefully those actually either you are learning, you're doing your first year, second years of foundation and university at college, you'll benefit from some of the existing technologies out there will actually make your learning experience actually more a pleasure one. Maybe you are a lecturer, you try to look for certain tools that actually help the student to grasp the concept you try to deliver to them easily. Either you're teaching or you're learning, I believe that for next 45 minutes, you'll benefit a lot. And we will try to cover for the fundamental, something that everyone can relate to from day-to-day learning and teaching to something slightly advanced. Hopefully you'll be inspired. Not just that, how actually you can relate to your assignments that you're trying to teach your students or you're trying to complete for submission. You also know that the technology out there will lead you somewhere. So hopefully that you can utilize it to make it to a solution application that not just actually help to earn a degree or finish teaching a class, but also actually complete a project that beneficial to the societies, the communities, or the people you want to help. So to cut the whole story short, and we have 3 more sessions coming up after graph logic and trees today. Next week, same time, 10 o'clock in the morning, we have applied statistics and data handling. Either you're handling financials, statistics or business statistics, econ statistics, or some scientific statistics or engineer statistics, or welcome. They are all interrelated. And on 29th July, same time in the morning, also 10 o'clock, we actually focus on vectors, metrics, and multivariate optimizations. So today we are focused only on 3 parts. So either you are in the discrete math on computing the mathematics, you can run away with dealing with graphs, logic, and trees. So today we spend a little bit about 30% of time in handling about logic. I'll spend more time in graph and network, about 50% time, and left the remaining about 20%, we discuss about trees. So not to worry, we will spend 15 minutes after the 45-minute sessions. If you have some Q&A questions, hey, how do I get certain things done, and how do I get this thing covered, and if you want to pick up what you have shown us so far, I find interesting, how do we move on? Yes, not worry, our facilitator, Desmond, today, will help you to communicate through a chat room, and after many 15 minutes. Now, let's move on. Again, not to worry, those things actually, if say, hey, Peter, can I have this information? Yes, you can have it after the session, you can have these things, no issue at all. Now, if you talk about logic in Boolean algebra, and frequently we from very fundamentals, propositional the logic, all the way how to deal with Boolean table. This is something that we usually concerned about. So I go to very fundamental first in the first 5 minutes, then I go something actually relate to your day-to-day learning and teaching experience. In proportional the logic, the basic 6 you deal with, of course, negation from conjunctions, you could be familiar with already. These are year 1 student in discrete math, or exclusive or, disjunction or, biconditional, implications, and you see those, even those that are using different type settings, but inside Wolfram Mathematica, I hopefully that you have downloaded. If not, I believe that you'll find a way to download one for yourself. You can try it out. You can use it for 1 year free, free professional license. If you're coming from certain university, you can try it out. The type setting here are fairly simple. Plain English, and you can use some of the commonly used proportional, proposition, logic that used in other programming language, some Pythons and R and C, Visual Basic like that. Those are simple things. So let's take a quick things. For instance, here, let's say P be a proportional, I'm attending a discrete math. Q be proportional that I'm a year one college student. That P be true and Q and true. And this one is something simple, so we not spend a lot of time that I just try to illustrate to you the type setting you're using in the Wolfram language to help you in teaching and learning is very straightforward. So you see whole thing in the screen I'm using here as a slide presentation, very much like a PowerPoint. Yeah, you can use it as presentation, you can use it word processing, you can use it for your word deployment or project deployment. So in this case here, the whole thing we type here, this is called scripting. Yeah, you can go to low level programming and coding. You can go scripting like this as well. So in this case here, if I'm using P and Q, that means this both conditions had to be true. So if I run this thing, you give you output like that. Yeah, if I say P and Q is true, then I try to run this thing again, give me true. And again, the next example here is negation. I'm not attending discrete math. So displaying English, not followed by square bracket, the syntax here, telling you P is not true. Then again, disjunction inclusive, or meaning that I'm attending discrete math, or I'm a year one college student, or the both is also true. So in a Venn diagram, it looks like that. So inside the coding, very simple, it looks like that. Now, the next thing is exclusive or. Yeah, I'm attending discrete math, or I'm a year one college student, but I cannot be both. So in Venn diagram, it's very simple. So inside, again, the coding, very straightforward. Same thing here, this called implication. Is like, if I'm year one college student, then I must be attending the discrete math class. So this actually means that P implies a Q. If P is true, then Q have to be true. Q can only be true when P is true. Same thing here, if talking about biconditional, that means that the implication is two directions. If I attending a discrete math class, then that means I'm year one college students. If I'm year one college student, I'm compulsory to attend discrete math. This is called equivalent. If P is true, then Q must be true. If Q is true, P must be true. Now, enough for this very basic fundamental. Let's go to something slightly more interesting. This whole thing is an example, so we can download the whole file, go back and try it out. How do this actually proposition logics works actually in a very simple way? Now, of course, we are not contained with this very simple thing. You can actually have done this thing in many ways. Actually, using human mind, you can quickly calculate it. The important part when it comes to Boolean algebra, one of the things is, of course, you have to deal with truth table. Now, the truth table I'm using here very simple, P and Q. In this case, I'm using a disjunction. That means that P or Q. If I want to construct a truth table for the disjunction between P and Q, I use a Boolean table like this. So inside the coding here, very simple. So again, you say, Peter, how do I know this syntax? Again, a lot of syntax here are plain English. Later on, I will show with you, you'll be shocked. Yeah, I can even type in a plain English word, then you give me all the result automatically. Of course, it will not give me a answer specifically, but give me a result in a very generic way, that for you to understand and digest. Now, let's say I want the result in a very specific way. I should look for something called Boolean table. Yeah, let me see. Okay, I have defined P and Q to be true in order this thing to run. Okay, now let me go back there. I already P and Q and true. Oh, let me clear it up first. Because P and Q previously have some value inside, let me clear it up from system. Now, in this case here, is P and Q is not pre-assigned whether it's true or false. So in this case, immediately it gives me a Boolean table like that. So let's say I want it to be a table form and the system will show up very nicely. Something like what you will see in a textbook. The true table for the disjunction of P or Q. Now, enough for this simple example. Let's say we have a truth table, but slightly more complex. P with the disjunctions or with negation of Q implies to P and Q. Yeah. So in this case, I can tear it out into like 4 pairs of elements here: PQ, negation Q, P or disjunction or with negation Q, and P and Q. And the result is what I want to see. So now this is whole syntax. This is the whole thing I want to see. Now same thing, I just copy and paste all the elements here, PQ, logic, proposition inside here. Then I run it. So it gives me this result. Again, if I want to show it in the nicer form, and inside here, we have a lot of syntax. Again, like I say, you don't have to worry about how to actually find out syntax like that. And if as long as you type Boolean table, Wolfram Mathematica give you a lot of guidance, something like Wizard guide you through step by step. So that actually you do not actually memorize a lot of syntax here. So same thing here. If I want to make it be more comedic, so I say, hey, Peter, here do not have a heading. If I want some heading, something like what you do with PowerPoint, Excel spreadsheet, you just define the heading accordingly. So it come up with an entire Boolean table, no matter how the size is. So the whole result is very quickly. Of course, we say, okay, inside this Boolean algebra, we're not dealing with truth table per se. A lot of time we have deal with logic gate diagram. So sometimes I know for a lot of students, year one student, you might have had it say, hey, there's a lot of diagram I need to memorize. I'm not trying to provide you a trick here so that you can finish your assignment without understanding it. I'm providing you a means today that so that you can verify and validate result. So along with your learning journey, so that you know that what you have understood so far is true or not. During my college time, sometimes I look at textbook, except the time when I go to meet my professors or my lecturer or instructors, I can validate my thought. But apart from that, sometimes at home when you self-learning, there's no chance for you to actually to verify whether the answer you come up with is correct one or not. If you do not know whether an answer is correct or not, it's really little chance that actually you can very sure with confidence that whatever you have learned and understood so far is on the correct way or not. So now, I offer you, in this station here, if you want to come a logic gate diagram, let's try to visit the previous this proposition logic. So the propositional logic, like in this case, very simple: P disjunction or negation R, and negation P disjunctions or, and so on and so forth. If this whole syntax here, let's say I want to turn the logic gate, how do I do that? So if I put this thing, yeah, it come out result like that. Of course, this symbol, it will come out syntax. This is something nicer symbol. So inside this Wolfram Mathematica, you could have very nice symbol looks like in a textbook. Same time, you can come out symbol familiar with those programmer. But let's say I say, hey, I don't want this thing like that. Can you give me a full form? Full form means that I want to see in a very original way how the syntax will looks like. Yeah, the full form in the system here come up with something more plain English. Say the whole thing here from the programming way, how programmers, coders understand how to put in Python or R or C. This usually put in, but at the same time, of course, you accept coding like this most of the time. But now in Wolfram Alpha, I think today I'll not explain about what Wolfram Alpha is. But if you're first time hearing about Wolfram Alpha, what you need to know is Wolfram Alpha is something, is an AI engine built inside Wolfram Mathematica, also available in the website free of charge, and allows you to try to mixing sense what you try to speak in English. So if I today type English like that with this thing, how do I come up with this thing? I type equal sign and I hit equal sign 2 times, this thing will come up. So these 2 things actually means something similar. So if it means that I try to key something plain English. So you can type in equal sign, say that, hey, the distance from Earth to Moon. It will give you the distance between Earth and Moon with different days and different time. So same thing here. If I type in plain English about my propositional logic, so immediately say, hey, this is something, is this something you try to understand? So immediately it comes out a truth table for you. So I do not even have to type in the coding that I just shown you just now with a Boolean table. It comes out like that, the truth table immediately. And the minimal forms, yeah, different formats, with giving you the same result, but in different forms. You see they all together come out additional 7 alternative of forms for you to understand from. Yeah, there's some even other form. Now, the logic circuit now has come out here automatically. Immediately you can see, of course, you will not come up detailed labeling. So in this case, at least you know how the logic circuit will look like. Then again, you go there and further understand and put in labels accordingly. And the whole Venn diagram, immediately you know how it looks like. And the truth density, the density of the truth, 62.5%. This is how wonderful it is. You want to come up with this truth density, actually it's not that easy. Of course, down here, this is something more advanced called elementary cellular automations. The founder of Wolfram Mathematica, called Stephen Wolfram, he is quite a pioneer in the areas of this Boolean algebra. This is something what he published about 10 years ago about cellular automations. Yeah, if you're interested, you can look up his thesis about what he taught about cellular automation, how it can help to resolve some very interesting things like biologies and things like that in the world using this concept. Now, enough of these Booleans and this propositional logic. I'll spend about half the time now talk about graph and networks, because today I think a lot of us, you'll find the application, especially computer science and discrete math, that's a lot. I mean, you will not stop in computer science. People in areas of social politics and even in the area of machine learning and big data, it can't run away from this, because there's a lot of automation you can do with that. Now, if you look at graph and networks, again, in a type setting, people might say, hey, how do I deal with this type setting? In all this, the escape, EU escape, this is how we actually construct and some of the network. So now, if you look at how the network get constructed, so I explain now, this is something called graph. Yeah, so if I want to construct a graph, so for instance here, I say for escape EU 2, escape, one more time. Escape EU, escape 2, my type setting not really work today. It's okay. Let me try again. Here we go. Okay, I'll put aside first. I think I need to set my font to make it work properly. But now, in this case here, there's a few ways a key in type setting. Either you can manually type in, or Wolfram coming with a palette. Yeah, actually, it's the easiest way. If you on top here palette, something like the advanced calculator. When you have palettes coming out like this, I'm not sure you can see or not. Can you see that there's something palettes on the right-hand side? And there's a lot of things for you to actually choose from to key in all those connecting vertex, because so-called vertex and edge accordingly. So a simple function called graph, and with the vertex 1, 2, 3, 2, 1 to 3 connecting one another, it comes out with a simple triangle. So same thing, if you say, hey, I want to be a directed graph, something with an arrow, something pointing to something, especially you want to study how, especially like for instance, social politics, how one person influence that person, you might want to have an arrow key. So in this case here, you use directed edge to show accordingly. So this triangle, simple triangle, will show actually the directions with arrow pointing one to another. So enough of simple illustrations. A lot of time when you come to the network and graph, we can run away with a simple illustration, Königsberg bridge. So in the Königsberg bridge, something like same thing, as if asking you a questions here. In this altogether 7 bridges, how do we actually cross each of the bridge here one time? A very interesting, simple illustrations about we call Euler circuit. So for instance, today, if you were told to patrol your garden, I want to patrol every single street in my garden just one time without repeating it too many times, wasting my energy. This is called Euler circuit. The problem Euler circuit. Similar example here is called Königsberg bridge. So in this example here, let's say I come out a simple graph here accordingly, like this graph. And the interesting thing here, if we go to the textbook, you want to test whether the graph itself is a Euler circuit or not. actually you need to go through certain steps. It's not as simple. They have several theorems actually for you to go through the test a graph is a Euler circuit or not. It's important for you to understand, but sometimes let's say that the circuit turned out to be quite a big one. Actually, it's not that easy to test. But inside Wolfram Mathematica, they have a lot of functions for you to do testing. So when you know whether this Euler circuit or not, then you can decide what kind of methodology you want to deal with this particular graph or network. Similarly, when deal with Hamilton circuit in another way, it try to resolve the issue is if I have a series of vertex here or series of points here, can I travel every single point just one time? Just now in the previous Euler circuit, you want to travel every single edges to one time. But Hamilton circuit here means that the issue you try to resolve it, you want to travel every single point just one time. So same thing here. If I want to test whether this graph itself is a Hamilton circuit or Euler circuit or not in this graph, I can actually, very simple, I define this graph called M graph 02. Then use my test function to test accordingly to tell me that whether this is a Euronian graph or this Hamiltonian graph. So it turned out the graph of this that I just defined is a Hamiltonian graph. So now, knowing that actually system can quickly actually help me to discern between different types of graph. Let's say we try to come up another graph again. Now, if I come up this graph, something like this, if I take this away, this graph looks like that. Yeah, of course, you say, hey, Peter, you see, you have to type in a lot of this kind of thing. Yes, it's nice to have result, but it's a major pain on the neck, a whole bunch of horses. Later, I showed you how you can quickly import a huge network graph from Excel spreadsheet, like how you understand, how you put in pen and pencil using paper and in Excel spreadsheet and import inside to construct a graph very nicely, a huge graph. Now, in this case, if I have this network plotted up, I say, can you give me a shortest path? Now, if you have network plotted, of course you want to resolve. One of the common things you want to resolve is, can I find a shortest path between certain vertex and another vertex? Means that if I want to travel A to K, can you tell me what's the shortest way to travel? System tell me that to go to A to K, I have to go through A, B, C, K. Of course, in this situation here, the chart, the graph here is very simple. I do not put any labeling. Yeah, so you do not know where's A, B, C, D. Those are slightly more incomestic. I'll show you more later on how to add in some of the labeling so you can understand better. Similarly, since I know this is a Hamiltonian graph, meaning that it actually allowed me to cover every single vertex or every single point just one time by traveling just one time. So then a shortest tour is possible. So in this situation here, I use a simple function called shortest tour. Immediately, it plot out how the shortest tour is made possible by visualizing this. Now, enough of this explanation. Let's give me slightly more comestic. If I want to look something comestic, here I can actually start putting in labels. For instance, this case here is showing a relationship graph, yeah, from Nazim all the way to Muthi to Lisa. I want to put a name on top instead of no labeling. Of course, you say, hey, Peter, if I can label vertex, can I label edges? Yes, by all means. Now, in this simple relationship graph, let me just try to generate something slightly more complicated. Inside Wolfram Mathematica, if you want to do your homework or you want to test out the concept or you do for teachings, sometimes you do not want to construct graph from scratch. You just ask the system generate random graph, just how you ask a lot of system generate random number. So in this case, I want system generate 15 vertex for me with 30 edges randomly. Now, and this system here, I want to randomly generate with direction. So in this case, you see some of the vertex here have arrow pointing in and out, bidirectional. Some vertex have incoming the arrow without outgoing. So it actually generates something random with 15 points and 30 wedges here. So all that together here, it also give me a vertex label name automatically, 1 all the way to 15 vertex altogether. So now, if you say, hey, Peter, this looks very nicely, I can copy and paste inside my PowerPoint and Microsoft Word? Yes, you do. But most important thing is, if you want to put it something computational manner, inside Wolfram Mathematics, there are a few ways to generate matrix. So you can generate adjacent matrix, meaning that vertex to vertex. And for instance, if I have 15 points, in this case, 15 vertex generate 15 by 15 matrix, telling you that from vertex 1 to vertex 15, whether it can go here and there or not. If you can, you put as 1. You cannot put as 0. This is something that and you can export the Excel spreadsheets nicely. Immediately, since you're clever people, if you know this actually adjacent matrix can be exported, means actually it can be imported as well. So that means that you can construct any matrix in any Excel spreadsheet or text or CSV file and import it. The system will create the graphic and then will automatically in a very nice visual, very nice visual way. Now, the next thing is if we can actually export import, the next thing is something might cross your mind. Say, hey Peter, if I can actually import export, I can actually try to come out shortest tool and shortest path. What if every single vertex, every single edges will have different weightage? This is very important because we don't want to have a system to tell that where it could go, where it could come from, where to go to. But certain direction might have stronger weightage and lesser weightage. Those stronger weightage where you may have tendency to go there compared to those lesser weightage. So it will come out different costing, to come out different overhead. So in this case here, now if I have actually a matrix like this, yeah, this is a very simple matrix called M01. If I want to visualize it in a metric nicer form, so I say matrix form. Now, simply called matrix, yeah, it looks like that, yeah. Assuming I imported from somewhere. Now, with this matrix, immediately I put inside here called adjacent graph. The system immediately will pick up this matrix and plot me a graph like this, yeah. And also with all the name called V1, V2, all the way to V13, I think, yeah. We have 13 vertex here, yeah. So in this case here, now the next thing is I say each vertex will have a weightage. So if I have vertex weight here, all 13 vertex have different weight. I can actually assign called vertex weight. The same thing called adjacent graph, the same matrix here, map 01. Now I say I want to assign my vertex weight according to this vertex weight array. Yeah, this array could again coming from Excel spreadsheet, or you can manually type in here. So even though you not see visually there are any different, but system already know. Now every single vertex here will have different weight. So now, and the next thing is I say, hey, every edge also have different weight. So I assign my edge weight here called my weight 01. I run it, it turns to black color. That means that the value goes into the memory of the computer already. Now, again, this vertex weight assigned here. I say the weightage weight here is equal to the array of my vertex weight. Now, assigned to this metric form. Now, if I run this thing, again, come out exactly the same graph, but this graph will contain two important values. The weightage for the wages and the weightage for the vertex. So it goes in here. So now, if I wanted something more comextic, yes, you do not have to know actually how this thing I did it. If you actually go through sound video, you find that this is valuable for teachings and learning. In fact, a lot of video about 15, 20 minutes available in our website. You can pick it up very easily how to do this coding. And a lot of coding when typing actually have videos to guide you through. So I myself do not actually memorize a lot of these functions here. I just type along the way, the system guide me through. Now, the system now is show me all the weightage assigned to the vertex as well as the edges. Now, in this case here, if I try to look up the shortest path and the shortest tool, the entire result and gameplay will be different. So if you can memorize, actually members the previous actually things that I showed you, this entire thing actually is now very different. Now let me try this. Put Ubi. Okay. Now you see here, and if you do not assign a weightage here, the entire result will be very different. Now in this case here, if the system can actually find out the shortest tour and shortest path according to the weightage that assigned to the system. Now I try to show you now how we actually do the importing. Now the interesting here is, let me show the screen on my Excel spreadsheet. If you have a simple Excel spreadsheet like this, yeah. So if I have a metric showing me, this is simple logistic table showing that how actually I should send my logistic route from Port Klang to Klang, Alam, Kota Kemuning, Damansara, and Puchong. And some of those say not available, meaning certain routes are not available. Of course, Port Klang to Port Klang itself is not available, Klang to Klang itself is not available, and maybe to Damansara to Port Klang also not available. So in this case, I put not available, and each of the route there also have different costs. If you see here, I'll assume that if I have sent someone to dispatch something from Port Klang to Kelang, they're actually about 100 ringgit. So same thing to Port Klang to Shah Alam is 200 ringgit. Also have location costs. The meaning that if I send something to certain cost area, you have operating costs. Yeah, and this cost, and you could understand right now, it could be equivalent to the vertex weight. Now, similarly, I have this location coordinate. If you have GPS coordinate, of course, in key in X and Y. If I do not have, I just simply type in 1 and 3 using my whatever assumption I have. Similarly, every single route here, if I put it inside the route, for instance, every single route also have a different cost. Meaning that from this Port Klang to travel to Kota Kemuning, the cost could be higher. Maybe you need to go through a higher number of tolls, or have to go through more traffic jam. So now you can relate. Now it could mean that this is the weightage for the H. Now, the last thing here, every capacity, every single location also have capacity. If I want to send something to some place, not every place actually can hold everything. That if today I want to calculate shortest path, certain path actually the whole location fill up. Especially today, if I want to put input or something, let's say 5,000, later I can do analysis, and eventually when I flow through a whole thing, how many actually things I can dispatch through entire network. So we can put in entire logistic problem inside Excel spreadsheet like that. So very simple. Let's go back to Wolfram Mathematica. The whole coding is just a few steps. Now, inside this here, I say I import it from my Excel spreadsheet like this. So the whole thing just using one function called import. Import what? Import my Excel spreadsheet. I want to import from my sheet number 1. I want to import second rows onward, everything in from second row without a header. Now, the system now imports successfully. The next thing is, after importing, I just want to do some cleaning. I want to do some domestic cleaning. So I want to say, hey, now, whatever represent 1 actually is Port Klang. Whatever is 2 actually represent Klang. So on and so forth. So later on, when I block the labeling, I can actually understand it. 1 is Port Klang, second is Klang. So say second thing, I want to import my Excel spreadsheet again from sheet number 2. Sheet number 2 actually is meant about my transportation cost. So in this case, actually represent my H weight. So now I assign my H weight accordingly. Similarly, I want to assign from sheet number 3, this will be my location cost, my vertex weight. So now the whole system now ready. It showed me that among these altogether, 6 locations will have different traveling costs and location costs. So now the last thing is I say, hey, I want to import my GPS coordinate so that I can plot it on my Google map. Is it possible? Yes, it's possible. Now, this thing, if I do not use actual GPS coordinate, so I'm using some XY randomly, it shows up as if this is a map. This is not a true map. I just simply make some assumption. Now, if I say that I want to get the shortest path from 1 to 3, yeah, 1 to 3 meaning that from Port Klang to Shah Alam, what's the shortest tourist travel? Immediately it give me a plotting here from Port Klang to Shah Alam. The next thing is I say, hey, if I want to travel the whole process, I want to cover all 6 different cities. How should I travel? It shows that I should start from Port Klang, go to Klang, Shah Alam, go to Kota Kemuning, Puchong, Damansara, and go back to Port Klang. So this entire solution is up. Say, Peter, okay, this simple thing I can actually ask my student to do manually. But let's say we go to something more ambitious. Now, In a Chinese postman algorithm, something like the uranium problem we try and resolve. So the uranium problem we try to resolve is if I were a postman, I want to go through every single street just one time without repeating my route. How do I do that? But it does not mean actually a lot of time the street is not interconnected. You know, in Malaysia street lah, it sometimes go somewhere you thought you can leading some tunnel is dead end, very common. So in this kind of situation, can we still resolve this? So now let's see what the system have available for us. Similarly, if I use a previous graph we created, the function was simple, find postman tour. This one major function here, inside Wolfram Mathematica, we have a lot of function built in. You do not have a download library. Yeah, like for example, you deal in Python. Of course, Python, someone who could have probably developed something called like postman algorithm. It could have, but you need to download, you need to know where to download. Yeah, there's no issue. If you want to do that, it's okay, it's good. But inside here, Wolfram Mathematica platform, I want to show step by step how this Chinese postman algorithm help me go through, travel every single edge just one time. I can even plot it out, animate it. If I want to animate, yes, I could animate, but I don't want to animate. I just show it one by one like this. Yes, it's showing me altogether 13 steps. I will cover every single edge one time. Now, if I want to go something more aggressive, if today I already know I have a super function called find shortest tour or find shortest path. If I know every single coordinate or the city in Malaysia, Wolfram built in with a lot of repository. Yeah, those actually attended our session before, you know how powerful repository are. Repository is something about public data that people uploaded for research, for development purpose, and is a validated data in a certain pre-configured format, so we can easily upload, update it, and download and share it with the community. So Wolfram have a lot of public repository built in for us free of charge. You can get a lot of real-time repository like financial data, weather data, up to minutes, all free. You go to talk to certain government authority, you want to get certain data. It's very difficult, but you will be surprised. Wolfram have a lot of repository free actually about Malaysia. Same thing here. You might not know every single city in Malaysia, but in the data system inside Wolfram, you know about 120 over city in Malaysia, major city in Malaysia. So you also have every single GPS of those cities available. So if you have this GPS coordinate, meaning something like XY coordinate, what we have to do is I say, hey, if I have this 120 over city in Malaysia, can you give me the shortest tour? Yes, just one function, find shortest tour based on my GPS coordinate. Please convert all those city name into coordinate for me, and it show it to me. This is how I should travel from city 1 to city 117 to city 147 to city 9, all the way back to city 93 and connect back to the original point where it started, city number 1. So this is one complete tour in the shortest way possible using one simple function called find shortest tour. Of course, you say, hey, I want to visualize it. Yes, of course you can do that. If I run this thing, something called geographic, and geographic is this is map given by Wolfram itself. You also have a detailed street map, but of course will not be as detailed as complete by Google Map, which is constantly being updated. So of course you say, I want to superimpose with Google Map. Is it possible? Yes, you could do that. But in this class seems you're talking about logic, graph network, and tree. So we not go into details how to do that. But again, you immediately see these are shortest tour plotted based on 120 over cities that Wolfram already know. So we just using one simple function called find shortest tour. So similarly, if you want to make it something more interesting, let's say today, knowing that I do not have to concern about most of the important mathematical algorithm, which already made available for me for the network and graph inside, so I can do a lot of wonderful projects. So in this case here, if I want to find out, we have a function called GeoNearest. GeoNearest, you can find something near something. For instance, I want to find all buildings, all landmark buildings near KL. Yeah, the KL center is where KLCC lah. So Wolfram assume the center of KL is KLCC. So I say everything in KLCC, which is center of Kuala Lumpur, 30 kilometers radius. Please give it to me all the landmarks building the system knows about. Yeah, of course, there are more landmarks. Actually, you want are not here. You can update your own repository so the system can understand. If I do not do that, I should take the default. So system know between 30 kilometer radius from KLCC, those are important landmarks people know from all around the world. Yeah, for instance, from Petronas Tower 2, 1, Maxis Tower, so and so forth. If you go to KL, you know what those buildings are. Now, if I say that I want the same thing, the same concept, I want to travel all those buildings one time. Again, I use the same this simple function called find shortest tour. So immediately it gives me a result. If I want to travel every single landmark between 30 kilometers radius from the centers of Kuala Lumpur, this is how I should travel. Starting from Petronas Tower 2 to 1 to Maxis Tower and going back to Petronas Tower number 2. This is one loop. Then again, something more interesting is that, hey, Peter, I can do something similar with a law application. No, yeah, not even waste. Yeah. So in this case here, if I want to put in my pictures here, I make it something more interesting. I put in my screenshot for my video. I say, hey, if I do this thing, I put it on map here like this. If I make it bigger, actually it's my little photo here, I make it very small, so it will not actually make my entire map ugly. So this map like this is showing that actually this how I should travel from one building to another building to cover entire buildings between 30 kilometers radius and the center of KL. So now, if you try to do it with Waze, no, Waze cannot do that. Waze is trying to guide you with the shortest path, yeah, from one location to another location. It will not tell you the shortest tour. Shortest tour meaning that if I throw in X number of location, it will not tell you that where you should start traveling to another in order covering the whole area. No, we can't do that. So in our logistics and supply chain, in a planning, locating strategic locations, you need a system that help you optimize what is the shortest tour, the shortest path, so that only you ask Waze or the app like this to help to plan the journey. So in this case, this one is the most important optimizations in any operation planning. Similarly, say today, if I want to do something similar to Waze, yeah, I say I want to drive. Yeah, can you tell me that how much time it takes in driving? It say approximately about 3 hours and 12 minutes. If I want to cover every single point in this shortest tour, altogether is 99.7 kilometers. So this is by driving. Say, hey, Peter, by driving means actually can change to something else by walking? Yes, possibly by walking. Even you can change to something like by biking. Because in the city here, not every place actually allow you to do biking, walking. Like interstate highway, you cannot do walking there. You'll be captured by police. So the system knows there are certain interstate highway like North-South Expressway, you cannot actually do walking. Yeah. Now, same thing here. If I want to show the travel path, I say, hey, if I want driving, now I don't want to show just the path actually as if I'm using drone to fly. I'm using car to drive. It shows I see the red color, this is a driving path. If I want to superimpose both of them, yeah, actually the system will show looks like that. You see, here are just few simple coding. You can give me the result of optimization already. Yeah, if this is something I can fly with drone without the issues of strict. And now, or I choose to drive, this actually I should go with this tiny red color thing. Now, the next thing is, and today the illustration about network graph, I don't really want to talk about this, but because I think in the past few months, people are tired talking about COVID-19. I still find that there are many ways people do analysis COVID-19. We also had one about last month trying to do simulation about how virus spread. But today we are not doing simulation. Today using this network shows that do a basic analysis. Right? A lot of time when our government say, hey, we have new cluster here and there, how do we do that? Yeah, actually we have a very simple thing. Now I'll show you how actually you can identify a cluster. You can identify the contagious rate, things like that, very simple. But we are not doing simulation. Yeah, that's another topic. We also have people talk about how we using IoT to find out a potential outbreak here. There's a lot of interesting modeling out there, and you can do it using Wolfram. There's nothing will stop you from that. Now, again,
here, we have a lot of library called example data. So inside example data, you have series of network here. You can actually play with. Yeah, this network graph, we have like 100 of a network graph that you can actually download immediately, yeah, for you to play with, to understand, to teach, and learn. For instance, now I want to download something called human disease network. Yeah, this is something true data and coming from this repository. Again, I will not show the detail or let me see. I can come and plotting. Yes, this is disease data here like this. This is how it show how the disease spread from one person to another. Of course, this entire graph is not really interconnected. There's like individual outbreak. We cannot find interconnectivities. There's a individuals contagions, so somewhere down there. So some of the graph actually independence. You see here, these are multiple graphs, some are graph interconnected because whenever you have a person confirmed with a pandemic, you might not know where the source is. So sometimes you find individual cluster inside here. So again, I need to say this is not COVID-19 model, okay? This is something quite an old model. Yeah, I'm not sure it's H1N1 or something. It was like about 10 years ago. So I simply download from network. Again, you said, Peter, how do we download this? If you can recall, with the Excel spreadsheet I show you, adjacent matrix, you can create a matrix like this easily. We have about 1,300 points here. It's a small network. So now, if you do a basic analysis, it's quite simple. Now, let me see a basic analysis here. Now, if I want to do a vertex count, I want to see how many patients here. Altogether 1,284 vertex, maybe 1,284 patients available. So if you want to see how many times is being actually confirmed, how many H, that means it's confirmed spreading. So in this 1,284 patients, the confirmed path of spreading is 1,527. So if today I want to see the rate of spreading, is something like this. So I just use the H count divided by vertex count. So meaning that total spreading, yeah, versus the total patients is 509 divided 428. So a lot of government statistics is similar way how they calculate. So that means that one person will spread to 1.18, whether the curve is being flattened or things like that. Yeah. So in this case, this transmission is not that terrible. It's 1 person to 1.18. Now, in this case, if I want to show the vertex list, meaning that if I want to show the patient ID, like same thing, you look at data published by government, all the names are not disclosed. So they only be ID. Similarly, we will have all the patient ID here from 1 to 1,284 altogether here. So in this case here, if you could have an Excel spreadsheet, or let's talk dealing, let's say like US stable thing, dealing with millions of people, you probably have simple database set up. Yeah, you just import the SQL database or Oracle database. Wolfram that Mathematica handle very well in database integrations. So you can easily construct 2x2 matrix or table or array, and you can construct another name list with the ID. So naturally you can create a relational table very easily. And in this case, immediately I say, I want to find out, if you want to find out who are the majors person who actually spread the most disease. So there are a few things called centrality. Yeah, centrality, there are a few ways. Of course, when I put here, the three most commonly used centralities, first is degree centrality, betweenness centrality, and closeness centrality. When put here, it does not mean that this betweenness and closeness are good to analyze the disease or pandemic. I was simply putting here for a way to explain it. These are available. But immediately, degree centrality is very easy to explain. You see here, immediately I see there are people who are confirmed, there are patients, they caught contagious, but they stop there. But there are some people actually, they are interconnected to another person. It could be actually connected, spread out, or people spread to him. So we do not know. But if I say I do want to do some sorting, I want to see what are people, actually, for instance, the zero are good, meaning that the person get contagious and the affected and stop there. But there are some people actually like multiplier, they are so super multiplier. There's one person that they actually have a relationship with 50 over people, 30, 27, 26. now you know that some people actually have a huge way of actually being interrelated to other people. If I put a max number, very simple, and it shows the highest one is 50. But again, if I say, hey, I do want to know just just the relationship, how people get interacted with. If I put something called out, meaning that if I have an arrow pointing out, I want to show this. If I want to show this thing, again, I put sword. And this one meaning that how this person's plan is to other people. It means they have an arrow pointing out. So in this case, it shows that some people are arrow pointing out, some people are one person affect another 5%, one person affect another 8%. Again, this person is one person affect another 50%. These are super contagious people. Yeah. So in this case, immediately I can do some analysis already very quickly. Now, if I do further go down, between this analysis, this is a very important, for instance, is one study network. Yeah, this is something, the details theorem here, I don't want to give explanations. Meaning that this, for instance, you're talking about a telecommunication network. Yeah, you want to find out how important certain substation is. For instance, certain substation goes down, the whole thing goes down. You want to know how important certain substations are, how much the things have control. For instance, is certain actually patients at 5975, meaning that if I have a way to stop this guy, the whole thing, the network can actually break out. That means I can stop the contagions, something like this. This between this, for instance, you have a power station, some may have higher number of value inside a network. That means that this power station have more control over other power station. And then closer centrality means that which one person have actually best way to passing on the information. This one especially studied influence of politician people. If you want to have influence the entire population, which person need to influence first? The person actually have highest method to influence other people called closeness centrality. Of course, these are theory you can find all in the textbook. I'll not explain, but this one quickly give you all the value that you need so that you can actually sort it out right away. Again, this whole thing, again, same thing. It have adjacent matrix. Like I say, you can build it up. Adjacent matrix build in this entire network is important. It's 1284 times 1284. It's huge metric, not considered huge, it's small already. Talking about millions of patients, this is tiny. Actually, you can export the Excel spreadsheet. If I want to do community analysis, this is very important. For instance, this 1284 by 1284, you want to do a community plotting, you want to do manual analysis, actually difficult. You see here, immediately it graphically shows to me all the patient. This one immediately I can, for another way is cluster. Yeah, immediately they visually show me the cluster here, available cluster here in the place. Yes, here, this one cluster. Yeah, this is one cluster. Yeah, this is one cluster. Immediately I can identify where it is, but visually it's not enough. If you want to do a report, say, hey, I want to know which cluster is which. Immediately give me this is one cluster. These are patient ID. These all patient ID potentially form one community. Yeah. So immediately it's not how many clusters are here. Easy report. Actually, the whole thing is not that difficult. It just few line of code. You see only one line of code. You only have to import the adjacent matrix in Excel spreadsheet database. The whole result come out immediately. Now, these are now social political analysis about foreign child families in old Europe. This one, a classical textbook analysis, how social political influence or one person to another from this classical example from Mercedes family. So I will not explain here, but you download this file. When you download on this presentation file, you only have to click here. It points you the whole explanation we have prepared for you to show that how you do social political analysis in this graph network. Now we come to something called trees. Yeah, this is something. The last 5 minutes, I'll explain a bit about trees. Quite simple. If you understand network and graph, it's nothing fancy about tree. Of course, today machine learning or decision-making tree, I will not talk here. I'll just simply show to you how you actually can construct tree very easily. Similarly, here you use the arrow. Yeah, the system now will show you this tree plot. Again, you can import from Excel spreadsheet if you want to. It's a zero function called tree plot. Yeah, the tree plot here is show. Oh, this is a tree plot. From 1 to 2 to 3, how it's go tree plot. Yeah, And if I say, hey, I want to give different coloring, something more comestic, yes, something like that. There's a lot of comestic you can do. Yeah, this thing is nothing fancy. Yeah, you can go to a visit. You can show you that all different way of plotting you want very easily and programmatically. Meaning is that you can change your point here anytime. Immediately, the graphic here will change immediately. So you don't have to spend a lot of time doing using PowerPoint. Whenever everything's static, you want to change some value, the whole thing you have to redraw again. But now, the important things of when it comes to trees, the depth and breadth first search. Very simple. Only one function called depth first scan. Yeah, I scan my tree. This is my tree I just defined. Yeah, and I show it how it works. Then it say that if I want to do a depth first search, I should go like this: 1, 2, 4, 5, 1, 2, 4, 8, 9, 1, 2, 5, 10, 11. This is something like 1, 2, 4, 8, 9, 5, 10, 11, 13. Yeah, something like that. Yeah. Again, if I want to go do breadth first scan, similarly, it go through like this. Immediately give me a sequence. Yeah, of course, here it's slightly more programming. Actually, this whole thing is not needed. I put this whole thing is for me to print out so they can see easily how I can do the depth and breadth scan differently. So, of course, importantly, there's some other powerful function that built in. For instance, the tree plot, if I'm using a JSON matrix, it give me a tree plot right away. I can put in some matrix from Excel spreadsheet, yeah, very directly. And if I want to do clustering tree, yeah, if we do binary search and you find it clustering trees will be very helpful for you. Whenever you do a binary search, is a helpful tool. And here immediately from ababa, A, B, C, D, E, F, G, I do a clustering tree, it do it for me immediately. If I want to do a clustering tree even based on audio, based on image, yes, your system automatically pick it up and help me do a clustering tree almost automatically. Of course, you can put in more methodology inside if you want to, slightly more intermediate topics, but it's all inside there. Now, lastly, 2 minutes, I cover 2 examples, hopefully inspire a little bit how this thing can help you solve things quickly. For instance, when we're dealing with trees, one thing is you want to find a minimum spanning tree. It's something like the shortest tool, things like that, yeah? But of course, if you have a spanning tree, I want to find a minimum one. It helps me do a lot of optimizations. In this case here, for instance, I have a company do fiber network. Yeah, this fiber network, I want to make sure this fiber network, certain areas are, for instance, you need to cross certain roads or certain building blocks, you need more renovations. The cost is higher. I want using this spanning tree to find out what will be the lowest of cost to have lay the fiber so they cover every single important point. So in this case here, we simply take one example we download from website. This for Chicago is a very old classical example. Every single each here have different costs. It's quite similar with the shortest tool, but this is spanning tree. Now using 5 spanning trees, a minimum tree, define for me. You say, hey, the result come out right away. In order to cover the whole thing, this is the sub tree is come out with. If today I want to give some visualization, it showed to me on the original graph itself, the tree now come out with a spanning tree like this. Yeah, it shows this is one with the lowest cost. Similarly, another interesting example. Yeah, I'm not using Malaysia because Malaysia might not make sense because Africa continental is bigger. So I make some assumptions. Let's say I want to build a highway, yeah, interconnected on an existing road. Yeah, and how do I do that? Yeah, again, I do not have entire GPS coordinates, so I come up with some assumptions with some XY coordinate myself. So this whole actually syntax here you can ignore. This one is how I generate XY coordinate using some assumption. So now it shows that now if I use a spanning tree like this, yeah, a simple function, find spanning tree. This is the network called my tree with the XY coordinate I generate. I say, can you give me based on the distance? Yeah, the one I want to minimize is based on distance. Yeah, so I can build an interstate highway, interconnect all important cities in African continent. So in this case, again, I want to visualize it. Now it's how it shows. This is the spanning tree, minimum spanning trees, covering every single important city using the current interstate highways already have in the African continent. So today we study over time, but I hope that you will know how to go on with fundamentals using logic, graph, and trees. If you have any further questions, like, hey, how do I teach now? Is more resources available? Yeah, we are not taking something fancy. We have a lot of references. Mostly we refer to a lot of popular, this one of the popular textbook from McGraw-Hill. We take some example in science and convert into coding. So you see, a lot of codings we took it from, a lot of example we took it from there, and we convert in coding quite easily and teach in the class. Yeah. Similarly, if you say, hey, I want to learn slightly more about graph and network theory, these are some references that actually you can get from. Yeah. So we close for today. So I'll stay online for 10 more minutes. If you have questions and you are happy to stay back and to answer any question you already have. So now, thanks again very much for your participant today. So I hope that next week we are talking about statistics. So if you think that you're in an area you're teaching or learning a statistic, you want to find out if there's any tool can help you to get things done easily. We do hope to see you again. Yeah, thanks very much.